What if a star not far from us exploded tonight? What would happen to Earth in the hours, days, centuries after? Imagine you look up, and instead of the familiar night sky, you see a blazing light, brighter than the moon, burning across the heavens. That's the shock. A nearby star going supernova would transform our sky instantly, and could ripple through life on Earth in ways we barely grasp. We're going to walk through this scenario step by step. What that explosion would do, how our atmosphere might respond, what the consequences would be, and why. Paradoxically, it might also remind us how precious our fragile world is. First, let's set the scene. A supernova is the final act in the life of a massive star. When its core can no longer sustain nuclear fusion, gravity takes over and the core collapses. Then the outer layers rebound in an explosion so powerful that for a time it outshines whole galaxies. Most of that energy is released as neutrinos, but a huge fraction also comes out as high-energy radiation, gamma rays, X-rays, and cosmic rays. Now, in ordinary conditions, stars explode so far away that their radiation spreads out harmlessly. But what if one exploded close, say, within 30 light-years, or maybe up to 100 light-years? Many estimates put a dangerous boundary somewhere around 25 to 30 light-years. Within that range, the radiation could punch through our protective layers. If the star were a bit farther, say up to 100 or 160 light-years, there might still be effects, but less immediate destruction. So in our thought experiment, let's imagine a star about 25 light-years away going supernova. What arrives first is a flood of gamma rays and X-rays, arriving in minutes to hours. Those high-energy photons smash into Earth's upper atmosphere, breaking apart nitrogen and oxygen molecules. That leads to a cascade of chemical reactions, forming nitrogen oxides and other compounds that deplete ozone. The ozone layer shields us from the sun's ultraviolet radiation. If it's thinned or destroyed, ultraviolet light would batter the surface. Then, cosmic rays, charged particles accelerated by the explosion, arrive over months to centuries, further ionizing the atmosphere, creating secondary particles and continuing ozone destruction. With less ozone, more UV radiation reaches the surface, damaging DNA, killing plankton in the oceans, harming plants, disrupting ecosystems. The base of the food chain could collapse. Reef systems, algae, microorganisms, all vulnerable. On land, radiation exposure could rise. Some organisms might die off outright. Mutation rates might spike. Over years, the climate could shift. More aerosols and particles might trigger cooling, changes in weather patterns, possibly even a nuclear winter-style effect. Over centuries, the cosmic ray bombardment fades. Some ozone might recover, but the damage to ecosystems and species might last millennia. In past Earth history, scientists suspect at least 2 mass extinctions were influenced by nearby supernovas stripping ozone, hitting life with radiation. The twist is that supernovae are also creators. They seed space with heavy elements vital for planets and life. So the same explosion that might devastate life also gives us the iron, the carbon, the building blocks of future stars and planets. Another twist: we already have a sort of early warning system. Tiny particles called neutrinos flood out before the visible explosion. Networks of neutrino detectors, the supernova early warning system, would alert astronomers. That gives us a chance, maybe hours, to brace, to warn satellites, to prepare. In the end, this scenario reminds us how delicate our biosphere really is, how shielded we are by thin layers of gas and magnetism, and how much we depend on cosmic calm. So the takeaway: a nearby supernova could be catastrophic, but thankfully there are no known stars close enough right now to pose that danger. But the universe is full of surprises, so if you enjoyed this cosmic thought experiment, please hit like, subscribe, and join us for more stories from the edge of space.